Computer vision projects have been instrumental in the development of face authentication and identification software. However, these are just a couple of projects that computer vision can be used for. There are also projects that detect driver alertness and many other innovative ideas. In this video, we will introduce you to some top computer vision projects you may not have heard of. Player tracking solutions. One key area that computer vision is playing a huge role in is that of sports, particularly soccer. Computer vision is being used by referees to make decisions such as make offside and penalty calls in soccer games. It is also increasingly being utilized by players to track and improve their performance. With the help of computer vision projects such as Sentioscope, players can now track and improve their performance. Developed by Sentio, which specializes in artificial intelligence projects, this application is a dedicated fitness and tracking system for players. The company itself has a reputation for fusing computer vision and with sports training regimens. It basically operates by tracking the activities of players and processing their real-time inputs during games. These solutions usually analyze live feeds from high-resolution cameras to track moving balls, detect player positions, and record other useful information that no one can use to enhance player and team performance.
Technology is so advanced.
Due to the experience of the manufacturing company, the application is designed with machine learning and has over 100,000 player samples to work with. The benefit is that once the feed is recorded in 4K version, it is then uploaded into a cloud-based analytical platform for analysis. This computer vision-powered solution creates a conceptual model of the soccer field, representing the game in a two-dimensional world. This 2D model is partitioned into a grid of dense spatial cells. Each cell represents a unique ground point on the field, shown as a fixed image patch in the video. It has been noted, however, that computer projects are not only developed in sports to monitor performance. On the road too, some projects have been developed to monitor the performance of drivers in an in-depth manner. Watch the video till the end to find out more details on that. Speaking of details, this channel offers comprehensive coverage of all topics related to the future. Stay informed by subscribing to our updates. Facebook 3D Photo. Facebook, now known as Meta, is one of the companies that will heavily rely on the use of computer vision in the full actualization of the metaverse. But even before that, the company has taken advantage to allow users to turn common two-dimensional photographs 2D images into 3D images. This will allow them to view pictures from different perspectives by rotating, tilting, or scrolling. In order to achieve this, the computer uses computer vision to extrapolate the 3D shape, which is depicted in the one-dimensional 2D shape. While the feature was not so popular among Facebook users in the past, it is recognized by many as a result of the availability of dual-camera phones, as well as the ability of the machine to turn decades-old pictures into 3D images. In addition to Meta, other companies such as DeepMind and Nvidia are also exploring the possibility of using computer vision to help users enjoy 3D experiences.
It is going to be so fantastic.
But these projects are not just for fun experiences. Later on in the video, we will take a look at how some computer vision projects are used to prevent accidents. Google Translate. Over the past years, several tech companies have sought to invent voice assistants to make the usage of mobile phones even easier. We have seen the arrival of Siri, Bixby, Alexa, and Google Assistant all being introduced. Google in particular have gone extreme by using computer vision to develop translation services to phone users. Invented between 2015 and 2016, the Google Translate feature uses neural machine translation to deliver instantaneous and accurate computer vision-based translation. Basically, this functions with users using their phone camera to point to any written text and have it translated into any other language. The feature is said to have benefited a wide range of people across the Asian, African, and European continent. In addition to the Google Translate feature, there is the Google Lens, which helps to search what you see. With this, users are able to capture images available to them and find their names or descriptions on the internet using the feature. Perhaps even more impressive with the aforementioned language toolkits is the fact that they can now be used offline with no internet connection being required before they can be accessed.
How's that sound? Well, that sounds good.
According to Google, many countries don't have reliable internet, so it's important to be able to translate on the go. Driver attentiveness. Distracted driving, including activities like daydreaming, cell phone use, and looking at objects outside the car, is a major contributor to road traffic fatalities globally. But with artificial intelligence, we can analyze driving behaviors and find solutions to reduce the number of road traffic accidents.
Thank goodness.
This is very much related to the attentiveness detection, which uses AI to detect distracted driving and alert the driver to refocus their attention on the road. With this computer vision project, there are a number of sub-projects that can be tapped into. For example, Road surveillance technologies use various methods, including deep learning to monitor and detect violations with the passenger compartment, such as seatbelt use. Also, in-vehicle driver monitoring technologies use visual sensing, analysis, and feedback to infer driver behavior using inward and outward-facing cameras or sensors. These technologies are designed to improve road safety by monitoring driver behavior and alerting them to potential risks. Additionally, driver-facing video analytics use techniques such as gaze detection analysis, head pose estimation, and facial expression monitoring to detect the face and eyes. These algorithms can use deep learning to distinguish between attentive and inattentive faces, detect differences in eye focus, and identify signs of driving under the influence. Computer vision surely proves how far technology has come in the last years. The belief is that its influence will be even more significant in the future. Watch our next video on how the world will be in the next 1,000 years to find out more.